Hello and welcome to today's webinar on how multi-cloud transforms network architecture. We're really glad you could be here today. Note that there's a little announcement for some more details to look at that you should be able to see. We have a Q&A panel for you to ask questions anytime. My name is Henthorn-Iwane. I'm CMO here at Packet Fabric, and I'll let my colleague introduce himself.
Hi, my name is Shashvat Thakor. I'm a product manager at Packet Fabric.
Great, and so we're going to be dividing and conquering today and try to keep this fast-paced and informative. I'm going to be talking about the multi-cloud reality and so the network architecture challenges, and then just explain a little bit about Cloud Router and some of the benefits it brings. Josh is going to give us a demo and make this more tangible for you. So note that there's some great attachments that you can download. And again, please feel free to ask questions at any time along the way. We'll try to address them as we go, and particularly in the demo. If there are things that come up that you would like to just understand better, please don't hesitate. So with that, let's move forward. Let's baseline by stating maybe the obvious that multi-cloud is now the norm for enterprise IT. So according to the HashiCorp State of Cloud Strategy survey in 2021, 76% of enterprises are already in multi-cloud. Within the next couple of years, 9 in 10 enterprises will be in multi-cloud. It's just becoming how things get done in IT infrastructure today. Hybrid, of course, is also super common. Multi-cloud is just as common. And even if you don't have your own data centers or colocation, multi-cloud is becoming normative for a variety of reasons. Now, what's driving the multi-cloud architecture? There's diverse application requirements. For example, we see lots of scenarios. For example, let's say one provider like AWS is a primary cloud service provider for, dev and prod for digital, application development, things like that. But Azure's used for Office 365, and then there's .NET app porting. Maybe there's, GCP or AWS used by a digital division. Maybe there's, Oracle Cloud for data management or, HR information system hosting, those sorts of things. So diverse applications, mergers and acquisitions. Two organizations that come together in whatever formation, they bring their own respective application stacks, their cloud infrastructure stacks, and oftentimes that includes separate cloud providers. And, you can't rip and replace all of that overnight, and oftentimes it just actually lives on for quite a while. So you have multi-cloud. You have regulatory requirements, like financial services such as payment processing may require separate cloud providers for issuer versus merchant processing, as an example. There's just the matter of vendor diversification, risk management. So, for example, you might have dev in one cloud provider and prod in another cloud provider. Backup disaster recovery. There's a variety of these reasons why multi-cloud is becoming more and more common, right? And the reasons are proliferating, quite honestly. I mean, think about, there's the popularity of Google Analytics products, for example. You may have dev and prod in another cloud provider, but you want the analytics tool from some other provider. This is what's happening, just like infrastructure vendor diversity, cloud provider diversity is just sort of becoming the norm.
Alex, yeah, I totally agree with that. And if you look at the financial results of various cloud service providers, it is also quite evident, like growth of AWS or GCP or Azure, and even OCI, it's phenomenal.
Nobody is suffering a growth, problem in these major cloud providers. Let's also note that multi-cloud actually goes beyond the definition of just hyperscalers. There's also what some folks call the alt cloud, alternative or indie cloud sort of providers that have their own roles. Maybe bare metal cloud providers, others that are filling different roles. There are storage providers, etc. Cloud storage providers, disaster recovery as a service providers like WebAir and others. Multi-cloud is just becoming there's a maturing set of options, right? So one of the major challenges is connecting it all. And what we're talking about is interconnection. So let me just define what we're talking about, what we're not talking about in terms of the focus of this. If down at the bottom of this diagram, you have the users. They're sitting at home, they're sitting in offices, they're sitting in wherever they are, and the variety of different ways to connect to applications, right? To the infrastructure that serves up applications. They're coming over, a home internet connection. They're coming over a physical last mile for an office. They're coming over 5G or mobile. But all of those methodologies and the ways they get there, maybe via SD-WAN tunnels or SASE service, or just straight 5G into some concentrator, these are really just getting users to the service edge that's serving up the applications. But in the center of the enterprise IT architecture is what we would call the cloud core. It's this constellation of different cloud providers, colocation, et cetera, but very much multi-cloud oriented these days, that has to get connected together because all the mission critical volumetric workflows are moving between these different kind of pieces of the core IT structure. And today our focus is going to be on multi-cloud connectivity, but the same logic can be applied to multi-regions within the same cloud provider, colo to et cetera. So there's a broad set of needs for interconnection. And the thing is that the bandwidth demands today are not just steady state. Yeah, sure, you have a steady state of demand for certain kinds of workflows, et cetera, but you have seasonal changes, you have innovation and other kind of initiatives, and then you just have disruption, like an M&A or like a new product launch or a new market they're trying to get into or new regulatory requirement. Just standing up an analytics application could require the movement of a ton of data from one cloud to another. For example, this could be a data migration. It could be a data pipeline you're building that is new. So there's a lot of things that change quite dynamically today in the interconnection picture that are much more variable than what they used to be. So this is the challenge, because the interconnection picture has been one where you've had to rely on a lot of fixed ways of doing things, where you're relying on traditional means of connecting things. And that just robs you of a lot of agility. But let's think specifically about multi-cloud connectivity. The first way that you typically connect cloud instances, VPCs, VNets, et cetera, to the outside world or to each other across cloud providers is typically using internet VPNs. They're the default cloud connectivity option. But what are the limits here? Well, first of all, VPN tunnels really can't scale beyond about 2 gigabits per second. There's max MTU limits, and they're just computational overhead required to process encapsulation, encryption, all that sort of thing. So there's a practical limit to how big a tunnel can get at the end of the day. And if you're growing something at any scale, 2 gig is not going to be enough in a lot of cases. I mean, I think that the reality is that we're moving away from the 1 gig and under reality to more of a 10 gig, sort of connectivity requirement for many enterprises. I don't know if you had a comment there, Shash.
Oh no, yeah, I was just agreeing to the fact that it's going to require much more bandwidth now, and like the compute power and the storage that is used by a lot of enterprises is just growing by leaps and bounds. So
right, yeah, the amount of data being moved, whether it's like replication or migration or analytics or just average workflows, is growing steadily. Internet transport obviously is also inherently not secure. It's not predictable. There's no SLA in the internet. And you can have wide latency fluctuations, not just micro fluctuations, but over time, internet connectivity can really fluctuate on a day by day, week by week basis in terms of, or even hour by hour basis on latency. Those fluctuations are particularly damaging performance of TCP-based applications because of the effect it has on windowing. And so it's unpredictable from a point of view of how much real throughput you can get. Bandwidth is not equal throughput. finally, VPN tunnels can be rather fragile. So you have to have all sorts of VPN management solutions, and it's just very easy for VPN tunnels to go down fundamentally. So there's a lot of overhead in just keeping it all going. So if any kind of internet VPNs might be a decent starting place for cloud connectivity generally, but they're not your destination for sure. They're not going to carry you very far. And that is why you have services like Direct Connect and equivalent versions from other providers, because they offer performance, they offer some scale, they offer an SLA. They also happen to have some advantages in AWS in particular, but other cloud providers in offering a better rate in terms of egress data charges. So, since it's private, it's more reliable and secure, et cetera, as well. So that's all good, right? But one of the major sort of architectural sort of assumptions that can be made, and this is oftentimes reinforced by traditional telco approaches to multi-cloud and intercloud or inter-region connectivity for that matter, is that everything has a hairpin through a data center. This is suboptimal. And, the issue, there's a variety of issues. One is hairpinning through somewhere else is always going to create more latency. It also, in a sense, turns the enterprise into an ISP. You got to do BGP peering with every CSP. You might have to do across multiple regions. Yeah, you might have multiple data centers, et cetera. You have to have, significant infrastructure to handle all of that. This is a complex, non-trivial sort of network architecture. So that creates operational costs and some degree of risk. You have blended fault domains. So this is not a simple picture, and not to be taken lightly in a lot of ways from a routing and network operations point of view.
Definitely. I also agree, Alex, with the fact that different cloud service providers would be having different ways of provisioning. And so you need to be aware of, when you have multi-cloud architecture, you also need to be aware of capabilities of different cloud service providers as well.
Right. If we think about one of the principles of good architecture and just layering and especially any kind of way to automate is you need some levels of abstraction and orchestration. Doing the hairpin architecture and direct kind of BGP connectivity to each service provider, cloud provider exposes you a lot. It doesn't give you the abstraction ability to easily orchestrate as by comparison, right? So that's a suboptimal way to do things if you're going between cloud providers and frankly between cloud regions, even the same provider. Now, it's understandable why you might want to do that, because you want to get that direct connect style connection rather than using tunnels, et cetera, right? So there's a reason why things develop this way, but also because there's been a technological limit from traditional ways of connecting these things together. Telcos have always had to bring it back through a POP, basically your data center in some fashion. Now, people can have mixed feelings about analyst firms, but I thought there were some really good observations from Gartner on cloud connectivity architecture challenges. So first of all, they just basically state the obvious. If you use a public internet, basically you're going to have suboptimal performance. However, some other observations is that IT teams that rely exclusively on, for example, the public-facing ports and CSPs also experience performance cost challenges because of, publicly routed ports carry a higher degree of egress charges. So that's, there's a way to connect to those public ports, but has some issues. But if you're doing furthermore, though, if you're directly interfacing to multiple cloud providers, and I would say even for multiple regions, there's a lot of administrative management and financial challenges of just dealing with that, as we just discussed. And Gartner's observation is that with the growth of multi-cloud, hybrid multi-cloud, the requirements for WAN to cloud connectivity are really shifting to agility, and multi-cloud interworking. Interworking is not just interconnection, is being able to do it easily, right? Just make it work between them. And most existing architectures, this kind of hairpin architectures, are not getting that done. And so they have this term called software-defined cloud interconnect, which you could roughly categorize something, like what Packet Fabric does, sort of under that. But basically, they're saying that there's going to be big growth in the adoption of a, what we call network as a service approach to connecting to cloud providers, for these agility reasons, primarily, and to have more sound, unified management, automation, orchestration. And this brings us to the state of the art. The state of the art is not to hairpin. And by the way, it's possible to hairpin even if your provider claims to have sort of a way to connect things more directly together, because it really depends on where the routing instance lives. The state of the art is to be able to get private optical networking between all the major pieces of your hybrid and multi-cloud core infrastructure on a programmable, consumable, cloud-like basis. Basically, interconnection is now a cloud service. And if you are not orienting your network architecture towards that and being able to take advantage of that, you're going to be suffering a lot of risk and incurring a lot of waste and opportunity cost, because really the WAN is now consumable. It's any to any. It's a programmable, flexible, provider neutral reality that exists today. Now, in the case of Packet Fabric, what this really means is that we've created a new carrier network architecture. We are not a set of VPN overlays. This is not SD-WAN in that sense. We're not IPsec tunnels between cloud VPCs. We have a real honest to goodness network. We have our own optical network. We have least dark fiber, all that. We have an Ethernet fabric. We have hundreds of POPs. It's all API driven. So it's basically built like a SaaS from the ground up, but it is a large network. So 50 plus terabit, backbone. That's a big network, right? But it is private, it's secure, it's a 5 nines core SLA, with teeth, and because we own and operate this, we can provide real-time visibility, telemetry, including streaming telemetry, things like that. And it's flexible consumption. You could do this by the month and longer. And in some cases, between data centers, you can even do more flexible than that. So it is a new carrier architecture in a totally cloud-like consumption model. And so which means that instead of waiting days and weeks to get a contract, and weeks to months to provision, connections, you can make things happen in minutes. You're going to see this in the demo. And we have a variety of different services, including a multi-cloud routing capability, which is our focus. But we have, data center interconnect, hybrid cloud connections from data centers to cloud, et cetera, and lots of flexible ways to create an overall kind of interconnection architecture. But specifically our cloud router is architected to deliver multi-cloud connectivity at scale. It's basically what it is. It's a virtual layer 3 routed mesh service that leverages our backbone. We have basically, what happens is that when you connect different on-ramps together with cloud router, we spin up VRFs to automatically distribute across the network based on the placement of those connection endpoints, and to handle the actual load. So the entire architecture of cloud routers is distributed. As a note, there are some other cloud router type products there that are effectively hairpins, where you have one VRF instance in the whole world and everything hairpins through that. We actually have created a totally distributed architecture. And Shash, I know you could say probably more about that.
Yeah, sure. So as Alex was mentioning, Packet Fabric Cloud Router actually creates a single routing domain, and then you would be making sure that the Packet Fabric's devices would be peering with the cloud service provider's edge devices. And each cloud router instance is connected via layer 3 mesh over Packet Fabric network platform. so that every other cloud router instance is in the same routing domain.
Yeah, so this is a very, very sophisticated, highly scalable architecture based on a massive backbone. And we're talking about, a 100 gig bidirectional throughput through cloud router. It's the most scalable private sort of cloud routing solution available on the market by far. And that's needed because of the bandwidth requirements. To put in perspective, I think the closest sort of comparable solution, we're, I think, 20x the scale. It's that dramatic. So let's see if I can advance this. So you get direct multi-cloud connectivity, right? So you're not no more becoming a transit ISP as an enterprise. It's cloud native. So if you don't have colo data centers at all, no problem. You can just do cloud native networking via cloud router. Although you can also tie in colo, it's flexible. You can do tie in links to colocation data centers, supports IPsec VPN. There's some other cool things that you can do, but it's optimal routing. It's a 5 nines SLA. It provisions the minutes. You consume it by the month. And there is one of the attachments. There is a video that we reference, which is in Bright Talk that shows you how much better a cloud router connection is in terms of real throughput using a more real world type application, which is basically Kafka transactions between AWS and Azure. We actually tested this. You got twice the throughput via cloud router versus internet VPN when even limiting for the same amount of bandwidth and all that sort of thing. So it makes a dramatic difference to connect on a private basis through cloud router versus internet, for example. So you can build multi-cloud disaster recovery. I'm not going to belabor all these points, but basically there's, you can build disaster recovery scenarios. You can do cloud data migrations. We have one customer. There's actually a case study from one of our partners that talks to the migration of tens of petabytes of data between cloud providers, and there's no way they could have accomplished that without the scale and the speed and the rapid provisioning and the consumability in terms of they just needed it long enough to be able to do it, of cloud router. So with that, I'm going to stop the slideware, and Shash will let you take over and show us what this really looks like in action.
Yeah, sure. Thanks, Alex. So as Alex was mentioning, it is really easy to set up a multi-cloud connectivity using Packet Fabric Cloud Router. I really want to emphasize that it is highest velocity, easiest to use, and most economic solution for multi-cloud data motion at scale. As Alex was also mentioning previously, that at Packet Fabric, we own the entire infrastructure. So we lease the dark fiber in network, and then on top of that we have our own hardware in various POPs, and we provide the layer 2 and layer 3 services. Let me share my screen and then we can go from there. Right, so this is the Packet Fabric portal, and I wanted to first start with the documentation. So all the steps that I'm going to show is available in our awesome documentation. You can see the URL. Now we go to the portal of Packet Fabric, and now we'll create a cloud router. So you give the name. Here is the cloud router ASN 4556 by default. We select the region North America, and we select the aggregate capacity of the cloud router to be 1 Gbps. We see what is the cost associated with it, and we create a cloud router. That's it.
One of the questions that came up, Shash, is just about how the pricing model, the cloud router pricing model, just generally speaking, and we just saw an example of that. You can see pricing directly in our portal, but maybe you could just comment very briefly on the overall pricing model.
Yeah, so overall pricing model is that we provide different tiers of pricing for cloud router as well. So for example, you want to spin up a cloud router for your demo purposes and you want to have an aggregate capacity of say 100 meg, you have monthly recurring cost of $100 for that, I believe. And all the prices are available transparently on our portal. You can take a look at this in the documentation as well. And then if it is anything above that, if it is just within US, then we charge flat $500 monthly recurring cost for the cloud router. And then you pay in addition for each connection. And each connection, yeah, please go ahead.
Oh, I'm sorry, go ahead.
No, I was saying then for each connection, based on the capacity that the connection is, there would be additional charge. But from cloud router point of view, all the connections that are going anywhere are of the same price, irrespective of the cloud service provider. So if you are connecting to Azure or GCP or AWS, as long as the bandwidth is the same, the price would be the same.
So basically, you have two major components: the cloud router instance itself, and then the connections.
Correct.
And these are all primarily, really, you can think of this as on a monthly basis, right?
Yes, that is correct. It is month to month. So it's like pay as you use them. If you feel that you want to increase the capacity, we have that option as well. You could just go ahead and then increase the capacity. I'll show you in the demo, during the demo. And then if you think that you are done with your use, you can remove the connection, or it's quite flexible.
Okay, great.
Sure. So yeah, what we have done so far is created a cloud router. That's the demo cloud router is the name of that. And now on the right, you are seeing that I can have some actions. So what I'll do is that as part of that, I'll be creating a connection. So what I'm trying to achieve over here is to have a connection between AWS and GCP. So let me first start showing the diagram what we are trying to do. This is the Packet Fabric Cloud Router. On one side, you have AWS in US West region, and you have GCP Cloud in US East region. There are some prefixes that I want to share between the two. Basically, it just indicates that we'll be able to communicate between AWS and GCP. As this diagram is showing, it's just that it's not only that AWS or GCP is supported, we also support IBM, Oracle, Microsoft Azure as well. So having said that, let us go back to the creation of the connections. So I'll start with AWS. So I click on AWS, and then on-ramp, I'll be choosing West, so San Francisco. There are two zones over here. So I'll be using zone A. Basically, zones are giving you resiliency and redundancy. We have different switches and servers over the gear and other gears over for each zone. So that way your network is resilient. I'll have to use AWS account ID, and then I'll give the connection name. And for now, I'm connecting 50 meg just to show how it works, and place the order. So while this portal is showing that the connection is getting created, basically APIs are doing their work to communicate with AWS and then making sure that this connection gets provisioned. If you go to the AWS portal, you would be able to see the connection over here, AWS private WIF connection that I had just created.
And just really quick, there was a question about what's the full meaning of AWS. It's Amazon Web Service. Yeah. Well, that's the Amazon cloud.
Yes, Amazon Web Service, correct. And GCP is Google Cloud Platform.
Yeah, and then one of the other another question is, and I'm kind of firing questions as you're setting these things up, but there's a question about a limited parameter to a cloud router. I'm not sure exactly. You might want to clarify your question a little bit, but I'm going to interpret this as, how do you limit the, how much bandwidth you're putting through it? It's really about the connection speeds, that you set up. Is I think, I think I'm answering the question, but if I haven't, please re-ask it in a slightly different way so we can make sure we answer that question.
Should I continue?
Yes, please go.
Oh yeah, sure. So Yeah, so as you can see, this is the connection on the AWS side, and obviously I have to accept the connection. It is a layer 2 connection which is being established with the AWS, and once we go to the AWS portal, and since the state is available, now I would be able to create a virtual interface on top of it. So I'll go ahead and then create a private VIF for now. Then BGP ASN would be the cloud router ASN that we created, and that's 4556. So what I've done is I've created a private VIF over here. Now, as you can see, once you create a private VIF, you would be able to, sorry, the connection went away. So as part of this private VIF, you would be able to see few parameters. Now, these are the values that you have to bring into the Packet Fabric portal to configure BGP. So if we go to the Packet Fabric portal, you can see that the private connection has been created, but it's also showing you that BGP is not configured. So we will go ahead and then create a BGP session. This is the cloud router ASN, which is 4556. From AWS, I'm bringing the Amazon side ASN, that is 64512. I'll also have to bring these IP addresses. So it says Packet Fabric router peer IP and AWS router peer IP. Over here, AWS provides us these values. Your router peer IP means Packet Fabric router, which is here. And then Amazon is this guy. Now with AWS, there is they also provide this BGP authentication key, and which one needs to copy paste. And for the sake of simplicity, I'm just going to allow all the prefixes that are coming from AWS, and I'm also going to advertise all the prefixes that are coming to Cloud Router to AWS, so that we can proceed with the configuration. Here you are basically getting all the traffic engineering related information. You are making sure that you can also changes the value in the AS, prepend, and med. You have the information related to that in terms of in networking terms associated with each one of them. And having said that, you just submit, and BGP session would get established. Now, it takes some time for the BGP session to come up, because the configuration would be pushed to the router, and also both the routers, the one on the Packet Fabric side and one on the AWS side, need to communicate. So let us now try to create one more connection, which is GCP. So I'll go ahead and then create a GCP connection. Now with GCP, what you have to do is that you have to create a partner VLAN attachment with a pairing key. To save time, I already created one, and I'm going to just use that. So once you create the VLAN attachment, the on-ramp that I'm going to choose is Washington, DC, again 50 meg capacity, and the VLAN attachment name is here. Yeah, CR demo GCP East. You need to use the same name. Let's go. And I have placed an order for the connection. So while this connection is being created, as you can see, in the back end, again, the APIs are trying to interact with GCP side. And over here, you would be, if you refresh the GCP console, you would see that it is going to say that waiting for service provider, and then it would ask us to configure the options.
One of the questions that just came up is, and there's a number of questions here. I'm just going to kind of address them as it makes sense in terms of our flow. But can you use another prefix outside of a local link address? I'm thinking that might refer to possibly,
Yeah, definitely. So basically, Cloud Router also provides various capabilities, like you would be able to forward public prefixes as well. It's just that, let's say you are trying to communicate GCP with AWS S3, then we also provide NAT services where all your private infrastructure on GCP would be NATed to one public IP, and then that prefix would be sent over to AWS. So yeah, that is possible. if that answers the question. And I can show on the portal the NAT capabilities as well. I'm just waiting for the GCP portal to give me a go to configure this. Yeah, so as you can see now, GCP side, we have received the connection. We'll go ahead and activate it and then accept. So yeah, it takes some time to update this, and then I'll have to configure the GCP side of BGP settings as well. Now, since this is going to take some time, what I have done was I have already created connections from AWS and GCP, and then wanted to make sure that I could show the connectivity. So let me go there. So this is the pre-created connections. As you can see, I have WDC1 with West. And if I look at the AWS portal, AWS connection details, I can see that there are BGP sessions. So this is the BGP session that got created by providing the values. And then in the BGP settings page, you have again the view which I copied over the values and prefixes. So if you look at the routes, you are seeing received routes and advertised routes. The received routes are the routes that are being received from AWS side. So when I created the AWS connection over here, I made sure that AWS is sending this route to Packet Fabric Cloud Router. So it's being seen in the received part. And if you look at the GCP connection, which I had created, the same route would be advertised to GCP. So if you would go to the BGP session over here and then click on edit, and then you would look at the route, the advertised route would be what is being received from AWS. And this is being advertised to GCP. Again, going back to this diagram, this AWS 10.0.1.0.16 is received from AWS and it gets advertised to GCP. So that's what it shows, that it is being advertised to GCP. Similarly, we have received two prefixes from GCP. These are the ones. So 10.128.0.016, as shown in this diagram. These are the prefixes that are received. And since I created a transit WIF, I was able to show that the same prefixes are reaching all the way to the transit route table. So here I'm showing the transit WIF with the route table, where you can see that these are the prefixes that are received in the AWS transit WIF. So this actually shows that prefixes are being forwarded from AWS and GCP. Having said that, we can take a look at maybe AWS session, which I just provisioned, whether to see what is the details. And as you can see, the BGP session came up. So just in like few minutes, while I'm talking with you, I already established a BGP session. It is that quick. Like it takes maybe 10 to 20 minutes to set up this entire infrastructure, and you would be able to communicate with AWS and GCP in this example. Yeah, please, Alex, do you have like any questions here?
A couple of things. One is just addressing a question about how complex or costly is this to manage. I want to make a contrast point here. What we just set up here requires zero hardware, doesn't require data center, right? It's very fast, so it's all software driven. So think about the difference in terms of procurement, hardware management, the fact that we're essentially acting as your router, right? This is a service that acts as a router that does the routing, forwarding, and I think the NAT. Someone else was definitely interested in seeing the NAT functionality. We have a lot of functionality built into this, so we're abstracting away the need to set up hardware in a bunch of different places to connect these clouds together. So it really reduces the complexity and cost from that comparison point of view. It also gives you a single interface to manage through. So there's, hate to overuse single pane of glass, but it is really that one place to go, as well as you have one place to go get metrics and other sort of, telemetry data. So there's
yeah, and so definitely. And so I also wanted to show the documentation which I was talking about, that if you would go through this documentation, it just not only shows you how to set up the cloud router, but also to take care of the cloud service provider side as well. And it is really in detail. It talks about the connections as well as how to set them up. Now, if someone was mentioning that what kind of view we get, so if I take a look at the cloud router which I had already set up, as I was mentioning, you would be able to see various details related to BGP session. So if I go to BGP session, um, and here I am seeing the received routes, I am seeing the advertised routes, I would be able to see the router logs as well. And yeah, it's really quite intuitive to set it up and then use it. Um, Again, we also, as I was mentioning, that our entire product is API driven. So these are the APIs, the page that I have shown, and this is specifically cloud router APIs. Whatever you can do using the portal, you would be able to do it using the APIs as well. So this is the API reference guide.
And there was a question about what key role does the AWS play in setting up a cloud router? There's with, I think it's with third-party cloud provider, I think is what they're saying. It's really, you can think of that our cloud router is sitting in the middle, right? As a distributed service. You just connect your AWS or your other cloud providers to the cloud router. So really, AWS is kind of the um, is sort of hanging off, as it were, that VPC and its routing instance is hanging off a cloud router as well as the other cloud provider, and you can do this across multiple regions. So AWS is, you're kind of using cloud router as the routing forwarding hub for your various cloud regions across cloud providers, if that makes sense. So
And to add to Alex's answer, sorry, yeah, go ahead, Alex.
Go ahead.
No, what I was saying is to add to Alex's answer. Say you are connecting between AWS and GCP. You don't have to remember any of the APIs. You don't even have to worry about how both of them are going to communicate. You would just spin up a cloud router on your AWS portal. You would be configuring bunch of private WIF, and then same you would be configuring GCP VLAN attachment and bringing over certain information, and that's pretty much about it. Packet Fabric takes care of the layer 3 connectivity and peering information. So if that helps, it is just following the BGP protocol. Basically, Packet Fabric Cloud Router is one ASN, GCP is in different ASN, and AWS is in different ASN, and so they would be able to advertise and receive the prefixes.
And remember, this is essentially direct connection based, right? This is, what we've just demonstrated is private connectivity, equivalent to direct connect and GCP partner interconnect, and as well as, if it was Azure Express Route, etc. These are direct connections. These are private SLA supported connections. So these are not tunnels that we just set up. This is real, honestly, it is optical private networking.
Definitely. And to add to the point, this what I had shown was hosted connection, but cloud router definitely supports dedicated connection as well. So what you would have to do is that then order a cross connect, and then make sure that the cloud service provider has given you the LOA, and then you would be able to set this up. With dedicated connection, we can go up to 100 gig as well. You can have a dedicated 100 gig connection with the cloud service provider, whichever ones are supporting that. Yeah, please go ahead, Alex.
So there's a couple of a category of questions. We're getting a lot of questions. It's just great. One category of questions is how to connect other kinds of sites to the cloud router. And I think it's important to note that while cloud routers is really awesome for a purely cloud native set of connections, obviously there are other things to connect. For example, you have colocation data centers, and you want to tie those in because, for example, you have a database that is in the private cloud and, spanning cloud, right? On-site, off-site, as it were. The cloud router can also connect to colocation POPs in our network. So that's one way that you can connect other sites. And again, if it can be using our fabric and getting that private resilient SLA supported connection.
Definitely. So, as Alex was mentioning, cloud router is just not limited to hosted cloud service provider connections. You can connect to co-location facilities. You can connect to dedicated cloud service providers as well. And so, what essentially you are doing is that you would be ordering a port on Packet Fabric network, which would be there on a particular data center. And from there, you would be creating a connection to your cloud router, and that's it. Once you have done that, you would be able to communicate. Having said that, you don't, if let's say you don't even want to connect to any cloud service provider, but you want to make sure that your various locations have layer 3 VPN connectivity, you can obviously onboard the cloud router. Like all your different on-prem locations, you would be creating connections to Packet Fabric cloud router, and that's it. You have got your BGP connectivity taken care of.
In addition, another way to connect is we also support site-to-site VPNs.
Correct. So yes, that is also a good point. So let's say what you want to do is you want to take care of last mile. Well, as long as you have an internet connection, just use IPsec VPN tunnel and then connect to cloud router. And once you do that, you would still be using the private connectivity to the cloud service provider, which would save you the egress cost.
The other thing to just recognize is that if you have a hybrid cloud architecture that is incorporating multi-cloud, and this is an increasingly common scenario, it's pretty frequent that we see customers, they're using colocation facilities and their own sort of data center locations as hubs for their WAN connectivity to their various offices and other kind of end user locations. So that's another way, is to think about cloud routers sitting between multiple cloud providers, connecting your data center, colocation data center locations, and then if you're hubbing last mile connectivity into your colos, you can do that. And we there's a variety of ways to do that. We actually partner with some various providers who do that sort of last mile connectivity as well. We don't do that directly today, but we do partner for that. So there's a variety of different ways to get your user locations connected into this, hybrid and multi-cloud sort of architecture. The other thing, Shash, if you wouldn't mind, is just showing a little bit about the NAT.
Sure. Yeah, just a second.
Because that was definitely a question, and there was a follow-up. So the person was like eager to see a little bit more about that. Now, the relevance of NAT is not just cloud to cloud, but also for some services like S3, where you're going to a public interface. There's a variety of reasons why you might want to use NAT.
Definitely. So basically, it is as simple as creating a connection. Say you want to, on the AWS side, you have an option over here where you would say create a NAT capable connection. You would be able to select an on-ramp capacity and then proceed with creating the connection. And then once you create the connection, you would also be able to give information regarding which prefixes you want to NAT to a particular prefix. It is quite straightforward, and it is available in the portal. If you want to, if let's say you are not having if you are not having public IP address space, you can use this particular toggle over here, which says use public WIF, and then Packet Fabric would be providing you with IP addresses that you need to communicate with AWS public WIF. So what would happen is, the way I showed you the connection request that went to the AWS portal, similarly, another connection request which is specific for public WIF would go towards the AWS, and then you would have to create a public connection. Please keep in mind that AWS public connections take around 2 to 3 business days because it goes through a certain amount of approval. Same goes with Azure. Actually, for Azure, you have to send an email as well to get them approved for Microsoft PM. But through the portal, you would be able to create it. And again, also the documentation is also a great resource for you if you want to look into how to create a public connection. Since you have mentioned NAT, we also took care of one more capability, which is BFD protocol. So basically, BGP sessions have tendency that it might take certain time to detect that the neighbor is down. Typically, it is 90 seconds. But with bidirectional forwarding detection capability, with each cloud router connection, if the neighbor fails, we would be able to detect that quite early and say if your use case is financial transaction or it is if latency is really important, you would be able to use that and then make sure your traffic converges faster.
Great. Well, thanks a lot, Shashan. I'll bring us home. First of all, I'm going to display an important announcement related to gift card raffle winner. But if you haven't gotten a chance to download some attachments, please check those out. The Kafka video is fascinating because it shows you exactly what private connectivity means on a multi-cloud basis, and it's really eye-opening in terms of performance. So what do you do next? If you want to learn more, you can obviously visit our website, packetfabric.com. You can request a demo. You can follow up with us at sales@packetfabric.com. If you're still kind of on a gradual learning journey, please continue to check out our webinars, as we have them pretty much every other week or so. And just really grateful that you could join us today. Thanks, Shash, so much. That was great demo and really fun to present with you.
Thank you so much, Alex. And thank you folks for joining. And if you have any questions, please feel free to let us know. Try the cloud router. It's awesome.
Yeah, you can also go to packetfabric.com and actually start an account and actually get going. So there's a lot of different ways to take action and even just to start trying it out. So please avail yourself of those options. Again, thanks very much for joining us today. Have a wonderful rest of your day. Take care and goodbye.
Bye.